Good evening, students. Today, once again, I will repeat the explanation of energy. So, what is energy? Capacity to do work is called energy. Everybody knows that. See, suppose whenever we are doing work, so actually, what is work? Already we learned force into displacement, right? Force into displacement is the work done. See, suppose when we apply force on any object, okay, so that force will be converted into work. Suppose I have given an example. If you take a ball and throw it, if you throw the ball, what happens? You are applying force on the ball, then the ball will move. Suppose if you take this pen also, if I apply force on this, little force on this pen, it is moving, right? Means the force is converted into work. Force is converted into work. That means pen is doing some work to move. So when it is moving, it is acquiring some energy. That is, whenever the body is in motion, the energy possessed by the body is called kinetic energy, right? So when we are applying some force, the work will be done. And the capacity to do work is called energy. So when we are applying force, work is getting done. And this capacity to do work is nothing but the energy, right? Understand? So what is energy? Capacity to do work is called energy. That is the common definition. Everybody knows that. Capacity to do work is called energy, right? Okay. Now, what are the units of energy? SI unit is joule. The SI unit of work energy is joule. So 1 joule is equal to how many arcs? 10 to the power of 7 arcs. This you have to remember. SI unit is joule, CGS unit is arc. 1 joule is equal to 10 to the power of 7 arcs. Now let us see about the energy. So energy two types, right? So energy possessed by a body is of two types. What are those? Kinetic energy and potential energy. Kinetic energy and potential energy, right? Now here let us see what is kinetic energy. Kinetic energy is nothing but the energy possessed by a body when it is in motion. Okay, the energy possessed by a body, when it is in motion. Okay, when it is in motion is called kinetic energy. Okay, now see here what I said. From when we are applying force, that is converted to work. Okay, so work will be done by the body. So capacity to do work is called energy. Now let us see from here. Work done is equal to force into displacement, right? You know, you might have remembered Newton's second law. What is Newton's second law? Says F is directly proportional to mass into acceleration. That is F is equal to ma. Okay, so in place of force we can write ma, right? So here we will write m into a, right? Okay, now it is moving for a distance. Now work done means when the force is applied, the body will move for a particular distance. So from the equation, v square minus u square is equal to 2as. Okay, so for the value of s, we can just change the sides. 2as is equal to v square minus u square. Now we need the s. So this 2 and a are in multiplication now. So then it will become division if you change the side. So s is equal to v square minus u square by 2a. Let us substitute this value in place of s. Okay, so what we will write? V square minus u square by 2a. Now we can cancel this a and this a, right? So what is remained? M into v square minus u square by 2. This 2 we can take inside. If you are taking inside, we can write it as half. Okay, so we can write m half v square minus u square. Let us take half first itself. So we can write half m v square minus u square. Okay, if we consider the initial velocity as 0. Okay, if u is the initial velocity. Do you know this? In the lesson motion you might have learnt u is the initial velocity and v is the final velocity, right? This is the equation of motion, right? So in the equation of motion, what are the equations of motions? V is equal to u plus at is the first equation. Then second one is this one, v square minus u square is equal to 2as. and the next one is S is equal to ut plus half at square. These are the equations of motion. So in these terms, v is the final velocity, u is the initial velocity, a is the acceleration, t is the time. Wherever you are seeing the same terms. Okay. Now here, when a body is starting from rest, its initial velocity will become 0. If the body is coming to rest, then final velocity will become 0. So here, when the body is starting from rest, when you are applying some force, work is done, then the body come into motion. That means the body was at rest, then it is coming into motion. That means its initial velocity is 0. So when u becomes 0, what happened? What is remained here? F half m v square, because u has become 0. That is nothing but we are waiting for what? Work done. Okay. So whenever the body is doing work, means that is having energy. So work done is nothing but the kinetic energy of the body. That is kinetic energy is equal to half mv square. This is the formula for kinetic energy. Okay. This we can say as a work energy theorem also. What we can say? Work energy theorem. What the work energy theorem is saying here? Work done is equal to half mv square. Okay. Now here you see, kinetic energy is depending upon the mass of the body, and v square means square of the velocity of the body. Okay. V square means square of the velocity. Right. Now let us go for potential energy. Have you understood this clearly? Then let us potential energy. So what is potential energy? Potential energy means the energy possessed by a body when it is at rest. The energy possessed by a body, when it is at rest, or we can say due to position also, when it is at rest, is called potential energy. Right. So the units of potential energy are kinetic energy remains same. What are the units? Joule and erg. Joule is the SI unit and erg is the CGS unit. Now let us see the formula for potential energy. See, when a body is, suppose if you are lifting one body, suppose this is the book. Okay. Now I am lifting this book. If I lift this book like this up to a particular height, okay, this book is having some mass, and it is acting, it will be attracted towards a gravitational force, that is acceleration due to gravity, and we are lifting to a height, that is h. When it is moving up, what happens? The energy is stored in the body in the form of potential energy. Anyhow, when the body is moving, it will get kinetic energy. When it is moved up and kept at a height, it has gained a potential energy. Right. Okay. So here we can say the potential energy of a body depends upon mass of the body and gravity, that is acceleration due to gravity, that is gravity of the earth, acceleration due to gravity and height of the body. So on three factors, it is depend upon the mass of the body, acceleration due to gravity and height. So we can write potential energy is equal to m for mass and small g for acceleration due to gravity and h for the height. So this is the formula for potential energy. Okay children, subscribe my channel and please press the button like. Thank you.